Welcome to the Crazy Hat Chemist. So here we go with another awesome video here in honors chemistry or college prep chemistry, whatever you want to call it. That will be just fine with me. I am the Crazy Hat Chemist, and today we are going to be doing a worksheet on nomenclature, pen and paper on nomenclature. So some things that you need to know prior to starting this here with me is the following. You are going to make sure that you know, let me zoom out on this. You need to know your charges on oxidation, ions and oxidation numbers. And here is an example of one that I have in my class. Okay. So this is the charges of ions and oxidation numbers, and you should know these. And there's a flip side to this. So let's see, how I have this divided up is I have cations on the left-hand side, anions on the right-hand side. These cations are most commonly right over here, ones that are periodic trends. These anions are ones that are periodic trends. These are some transition elements which have multiple charges to them. And you should be looking at patterns on the periodic table to address those. In addition to this, you should have memorized your polyatomic ions. And I have cations on the left, anions on the right, because when we do come up with formulas, the cation comes first, then the anion comes second, most commonly when we're dealing with an ionic compound. Right down here in the lower left-hand corner, I have prefixes for binary covalent compounds. Okay, so hopefully that works out well for you. Notice that there is only one polyatomic cation, and that is the ammonium ion. I almost guarantee you that your instructor, your teacher, your professor will be using the ammonium ion in their nomenclature unit. Why? It's the only one. Look how the rest of this is blank on the left-hand side and how many things on the right-hand side you have. So here's my recommendation. You need to have these memorized. That is, you need to have the name memorized and the formula memorized, and you need to have it be able to go back and forth. And what's the best way, the easiest way, the fastest way to do it? No, it's not 3x5 flashcards. No, it's not Quizlet. And you might think that those things are fantastic and all, but that is not correct. The fastest way to memorize anything is to actually write it out and say it out loud as you write it out. Okay, so that is the fastest way. So think about it this way. If you were trying to memorize your lines for a play, or you're in if you're in a play and you want to memorize your lines, you don't use 3x5 cards. You run through the script over and over and over again. If you were to write it out and say it out loud, then you will be memorizing it faster than any other method. And really and truly, you need to spend about 10 to 15 minutes a night working on this. And then don't spend 30 minutes, don't spend an hour. Brief, short moments in time will keep your brain active and cognizant of truly what you're doing. Say it out loud, write it out. Okay, so please do that. You'll memorize it with less pain, and it will go into your long-term memory. That's the point of the whole deal. I will be using this periodic table. Let me zoom in here just a little bit on this one. Okay, so I'll be using this periodic table right here. Not everyone will be using this periodic table, but this is the periodic table that I use in my class. So before we get started on this nomenclature unit, I do need to give you some periodic trends, and periodic trends will be the alkali metals, which is lithium through francium, and then the group 1 is including hydrogen. So the alkali metals, including hydrogen, would be +1 charge. Okay, then we have the alkaline earth metals. That's group 2, and that is a 2+ charge. Then, so we're going to continue this positive charge, and that is, these are most commonly metals. The only non-metal is hydrogen, and many periodic tables have kind of like an orange staircase line. Where is that staircase line? That staircase line is right here, and I'll draw it out here on my periodic table. And this orange excuse me, this orange staircase line delineates the metals from the non-metals, and the metals are on the left-hand side, that's over here. The non-metals are on the right-hand side, that's over here. That's our black and white version. We do have some metalloids that we'll discuss in just a moment as well. So for the metals, they're going to lose electrons most commonly. And so we have a +1, +2, +3, +4, and a +5. And notice, and this is something that you should be working with here, the Roman numeral for 5 is what? A V. And so that coincides with that. So this is a +1, +2, +3, +4, +5, Roman numeral 5. Now I'm going to stop. At this point in time, I am going to count how many? 5. Why 5? Because this is a V, that stands for 5 Roman numerals, and that's a 5 plus. So 1, 2, 3, 4, 5. So these 5 elements have 2 charges to them. They have a 2 plus charge and a 3 plus charge. If you are using the common naming nomenclature and not the systematic naming, if you're using a systematic naming, then this is a Roman numeral 2 and a Roman numeral 3. But if your instructor or professor uses a common naming, then this will be having an ending of OUS, and this will have an ending of an IC. Then there is a hard stop because copper, you've been traveling too fast along the highway at a speed of 2 and 3, and then you see a copper behind you, and that copper is going to slow you down by just pulling off on the gas pedal just a little bit. And there's a 1 plus and a 2 plus charge for the copper ion. And the lower charge has an OUS and the higher charge has an IC. So you should see that the OUS goes with the lower of the 2 charges, the IC goes with the higher. The OUS goes with the lower of the 2 charges, the IC goes with the higher. There's another set of periodic trends, and that is in this diagonal pattern of silver, zinc, aluminum, and cadmium. So there's this diagonal pattern that goes right there like that. Silver has a 1 plus charge, zinc has a 2 plus charge, aluminum has a 3 plus charge. And then cadmium is in the same column as zinc, so cadmium has a 2 plus charge. These are the only charges that they have. They don't have multiple charges. Then we have gold. And gold has a common charge between the copper and the silver. And the common charge that copper and silver has is a 1 plus, so gold has a 1 plus. Gold is actually worth more than either copper or silver, so it also has a 3 plus charge. That's actually not why it has a 3 plus charge, because it's worth more. I'm just trying to get you a way to memorize it. Then we have mercury. And mercury has 2 charges. One of them is a 1 plus, so it's kind of like intersecting these two, and the other one is a 2 plus. Now, mercury is an interesting one because it's actually, both of them are a 2 plus, but there's a mercurous and a mercuric. And this is probably the most common, the most complicated. And this is mercurous, that's the OUS. And this is mercuric, and that's the IC. So those are the 2 for the mercury. And what differentiates the 2 of them together is this little 2 right there. All right, then we have another pattern here, and that is the tin and the lead. They both have the same 2 charges, and that's a 2 and a 4 plus, a 2 and a 4 plus. Again, the lower of the 2 charges has an OUS ending. The higher of the 2 charges has an IC ending. All right, we're going to continue along this little pattern here and go 1, 2. We're going to skip these transition metals and go 3 plus. So most commonly, this has a 3 plus in this column, and that goes with that aluminum, and you can see that. Now we're going to work with the non-metals, and the non-metals are in this column right here, starting and on the right-hand side of this orange staircase line. The noble gases really do not have a charge. They do not interact with other elements for the most part. And the halogens, that's fluorine, chlorine, bromine, and iodine. Those are the halogens or halide ions that have a -1 charge, starting with oxygen in this column, 2 minus. And then a 3 minus here, And then this column is kind of funny. It either has a 4 plus or a 4 minus, depending on which element it is. All right. I had mentioned that we will talk about the metalloids. And here are the metalloids. So 1, 2, 3, 4, 5, 6, and one of these is going to be 7. Most commonly, textbooks have 7 metalloids, and they are on either side of this staircase line, and it's either polonium or the PO or the AT, one or the other. The other set here is that we have diatomics, and diatomics are atoms, or rather, they're molecules that are in their diatomic state naturally. That means they are di. The prefix di means 2. So it's N2, O2, F2, Cl2, Br2, I2, and H2. So what are the diatomics? Those are these right over here. Okay. And let's see. So we've got our diatomics, we got our metalloids. I'll just shade those. I want to make a clear point that the metalloids does not include aluminum. The diatomics, I tell my students, you take your right hand, you make a gun out of it, and then you stick this on your forehead. And that typically means that you're a loser. Okay, but then you take that and then you flip that down, like you point the barrel of the gun down, you point it down, and then what number do you see? That's a 7. Do you see a 7 right there? That 7 is telling you how many diatomics there are. 1, 2, 3, 4, 5, 6. And where's the 7th one? Right over here. So how do we get to the 7th one? Well, if you ever play the game chess, you know, there's checkers, there's chess, there's backgammon, the game of chess. And there's a chess piece that is unusual compared to all the rest, and that is the knight. And it goes in this L-shaped pattern. So it's the only one that jumps. Boom, there's your jump to hydrogen. So those are your diatomics. And then there are 7 metalloids. And then there are 7 strong acids. So that's where all that comes from. At least that's what I tell my students. So I'm telling you too. I'm going to zoom into all this right over here so you can kind of clearly see all of this here very nicely. So that's all right there. So make sure that you pull out some periodic tables. And then what I would recommend doing is writing all this out on periodic tables multiple times. Like take 10 periodic tables, just start writing on them, throw them away, bring out another one, write on it again, throw it away, write on another one, throw it away. So that means that you will have memorized all your periodic trend charges after having done this. Okay, and then, so we're going to be referencing this. When I say that's a periodic trend charge of a +4 or a +3 or something like that, then that's why. And so that's coming from these periodic trends. So I'm assuming you know that. I will make the other assumption also is that these are periodic trends. Those are your transition elements. And I will make the assumption that you know your polyatomic ions and you have those memorized as well. Okay, so here we go. Let's start on this here. And I'm just going to zoom in on here. And then we have a bunch of problems to do. This is my nomenclature worksheet. Okay, so nomenclature worksheet number 1. This is my nomenclature worksheet. I designed this many years ago, and so we're gonna move forward with this. So here we go. So problem number 1. Let's see if we can tackle all of these here. So we have 2 things that we can do with nomenclature. One is that we have a formula. We have to come up with a name. 2, we have a name, we have to come up with a formula. That's effectively the 2 things that we need to do. And this is really the background information that you're going to need to know before you start chemical reactions, because you won't be able to do chemical reactions without having known your nomenclature. It's just impossible. Okay, so zooming in here really close so that you can see this clearly and all the little ins and outs that I will have. All right. Cool. Did you know that today's video is brought to you by the Crazy Hat Chemist and sponsored by the Crazy Hat Chemist? And that is me right here. All right, here we go, folks. This is sodium bromine as far as the elements, sodium and bromine. But when This is an ionic compound that is a cation and an anion. This is a cation, this is an anion. That's a cation and an anion. And I'm combining these two things together in their charge ratio that is appropriate. And so the naming of an ionic compound, which is a cation-anion combination, is the metal name, and then the non-metal, if it's not a polyatomic ion, has an IDE ending. So this is going to be sodium bromide. There is no name of a compound that has the name of the elements and the elements only. Okay, awesome. Next one is going to be Ag. Ag is for silver. Silver. And then this NO2, that is a polyatomic ion, and that is nitrite. Nitrite, nitrite. All right. The next one is calcium. And then this is also a polyatomic ion. Okay. Calcium is a group 2 and it has a 2+ charge, and the Cr4 is chromate and it also has a 2+ charge. So that's why the 2 2's disappear on this formula here. There's no 2 here and there's not a parentheses with a 2. So that's you have to reduce them. Calcium chromate. And this is as simple as you just have to have your ions and charges memorized completely. All right, let's scroll this on up a little bit. This is Au, and that's for gold. Okay, and now we have this OH, and that's hydroxide. And so I'm going to give you two names for this gold. The charge on the gold is right here. So I tell my students what you do is you take this number right here and this number right here. You take those numbers, flip them and bring them up. You take the bowl by the horns, flip and bring them up. There's your bowl. That is your index finger, your pinky finger. Your index finger is that 1. Your pinky finger is that 3. You're going to take the bowl by the horns. That's a 1 and a 3, 1 and a 3. You're going to flip those numbers and then bring it up. And then that will give you a 3+ charge on the gold. And this is the systematic naming. So it's called gold Roman numeral 3 hydroxide. Okay. The other way of writing gold that's a Roman numeral 3 is auric. AURIC, because it's the higher charge of the gold. So you can write auric hydroxide or alternatively gold 3 hydroxide. It's entirely up to what your instructor would like on that. Okay, this next one here is Ag2CO3. Okay, and there's an imaginary parentheses around here and a 1. That 1 comes up, this 2 comes up. That tells you that this is CO3 2-. That's carbonate. This is silver. So silver carbonate. And then you're going to ask me, well, why don't we have a Roman numeral for silver or for calcium? And the reason is that calcium is in group number 2 and it only has a single charge. And silver, I went over already earlier, it only has a single charge as well. So you cannot use Roman numerals. You cannot. It's not like it's an option. You cannot use Roman numerals when you have a single charge. This next one is mercury, and I had already written down the 2 mercury compounds, and that is right up here. There's the mercurous with that 2 and the mercuric without the 2 right here. They both have a 2+ charge. This is actually two mercury 1+ ions together, right? So this here is going to be and you need to know the charge on the sulfate. The charge on the sulfate is a 2-, and there's a 2 for that mercury. So we're going to take the bull by the horn, flip, bring it down, and then this would be mercury 1 or mercurous sulfate. So that would be mercury, Roman numeral 1 sulfate, or mercuric. Mercurous. And the reason it's mercurous is that 2 stays there because these other 2's of the charges actually reduce. All right, scrolling this on up here. we have Fe2O3. If you take the charges, flip them, bring them up, then you should see that the charge on the oxygen is a 2-, and that is the periodic trend charge that you would expect. And oxygen is a 2-. And then iron has two different charges, but this is the charge for the iron here. Okay, so that is going to be iron 3, because that 3 comes up. That's iron 3. So iron, Roman numeral 3, oxide. Okay, or ferric oxide. Okay, and this again is a non-metal, so it has an IDE ending on it. All right, fantastic. Keep it on going with number 8. Okay, and number 8, we are going to take this 2 and bring it up. And then, sadly, we cannot bring this 2 up because chloride does not have a 2- charge. It has a 1- charge. Okay, so because of that, this won't work that way. So any mercury compound, this is what I would recommend doing. We have an Hg 2+2, and this is mercury 1. And then I'm going to write down mercury 2, and that's Hg2+, and that's with the chloride. So that's a Cl1-, Cl1-. I'm going to take the absolute value of these two numbers, flip the numbers, and bring them down. So the 1 comes down, and then this 2 comes down. So this compound here is going to be Hg2Cl2. And then this one will be HgCl2. And then you can clearly see the difference between mercury 1 chloride and mercury 2 chloride. Okay, so which one is this? Well, you're going to compare these two to what you actually see right there. And let me scroll that up there so you can see all of it together. And you should see that that has that 2 right there. So therefore, it's the mercury 1 chloride. All right. Hopefully that worked out for you. So this is mercury, Roman numeral 1, chloride. And again, that's a non-metal, so it has an IDE ending on it, or it's mercurous chloride. All right, Rb is rubidium. That's just Rubidium, just like it's on the periodic table. And NO3 is a polyatomic ion, that's nitrate. All right, fantastic. All right, the next one is manganese. Not magnesium. Okay, so make sure that you understand that. And there are two different charges for manganese, and this is the charge for the manganese because it comes up there. So it's manganese Roman numeral 2, and that NO3 is nitrate. And this is also has a common name, manganous, MANGANOUS. All right. Sliding this up a little bit here. Okie doke. All right, so this is the only polyatomic cation there is. That's the ammonium ion, so it's ammonium. And this is a polyatomic ion, and that is phosphite. Okay, pretty simple. This is sodium and chlorate. That's a polyatomic ion. Sodium, chlorate. And then this one here is lead and sulfide. Lead, sulfide. However, this is a certain charge of lead. And so what we're going to do is we're going to cruise on over to our periodic table, and we're going to figure out what is the charge on a sulfide ion. It's a 2-. It has no other charge. And yet lead has 2 charges, a 2+ or a 4+. So we got to figure out what this charge is. So in order to do that, what we're going to do is we're going to do PbS, and this is a 1, this is a 1. I'm going to flip them up, and I get a Pb1+ and an S1-. Now, there is no S1- charge. So that means that this must be a 2 minus charge because I just showed you on my periodic table, it's the periodic trend for a sulfide is a 2 minus. So that means that these reduce. So this must be a 2 plus. So if I put a 2, if I bring this 2 down and I bring that 2 down, then they must reduce. So this is lead 2 sulfide or plumbus. Okay, so plumbus. Plumbus sulfide. That's the other one. Right, so that is number 13, my classroom number. So that's perfect. Okay. All right. So let's keep on going. We're going to do the other side over here. And I'm hoping that you notice, and I'm going to go back over here. I apologize, but I'm going to go back over here and you should see that just by knowing your polyatomic ions and their names, they just pop right out. If you don't know them, it's impossible. So you have to memorize your polyatomic ions and their names. It's just, there's no way about it. Okay, so make sure that you do that. Okay. All right, so this next one here is going to be nickel and oxalate. But we got to figure out what the charge on the nickel is because there are two different charges for nickel. And that is dependent upon the charge for the oxalate. So the oxalate has a 2 minus charge. And that 2 minus charge for the oxalate is going to come down here. But then you're going to have a parentheses and a number here. What is that number? Well, that number has been reduced and it's the same number. So that means that this is a nickel 2. So it's nickel Roman numeral 2 and then oxalate. So nickel Roman numeral 2 oxalate. And then nickel also has that common name, Nicholas. Yes. L-O-U-S, Nicholas. There we go. Like St. Nicholas. All right, our next one is ammonium. And then this is just an element, and its charge is a 3 minus, and you can clearly see that right here. There it is, phosphorus, and that is going to be a phosphide. Right, because it's a non-metal and it has an IDE ending on it. So that's ammonium phosphide. All right, so our next one here, we're going to have a 1 here and a 3 here. We're going to take that 3, bring it up, or take that 1, bring it up. That will give us a nickel. And it's a Roman numeral 3, chloride. And that's nickelic. Chloride. All right, fantastic. Cruising on up here. This is going to be a 1 right here. We're going to bring that up. The charge on this here is a 1 minus, and that's chlorite. And then this 4 comes up, and that is a 4 plus on that SN. And that is 10 Roman numeral 4 chlorite or stannous chloride, right? The next one here is HgCl2, and actually I had done this one already before, so I'm just going to slide this over here, and let's see if we can see both of these here simultaneously. So we're going to ask ourselves, which one of these is it? Which mercury is it? So I made the mercury 1 chloride, I've made the mercury 2 chloride. Which one is it? Well, it doesn't have the 2 down here, so it's mercury 2 chloride. And we already did the mercury 1 chloride on a previous problem. That was number 8. So this is mercury Roman numeral 2 chloride. Mercury Roman numeral 2 chloride. And that is mercuric. Okay. And then this next one here is, okay, so the next one has an AQ. Now, it does not actually need the AQ, but this is an acid. And there are two different types of acids. This is a polyatomic ion acid, and it is based on the name of this polyatomic ion. That has a 2- charge because that 2 comes up, and this is sulfite. And ite becomes us. So this is going to be sulfurous acid. Okay, sulfurous acid. All right, that's a polyatomic ion. It does not need the AQ, but that AQ helps in distinguishing that that is most certainly an acid, at least at this point in time on nomenclature. Don't think that all things that have AQ are acids. That is certainly not true. Okay, all right. So the next one is Cr. That is chromium. And what's the charge on chromium? It's right there. So it's chromium 2 and then bromide. And that is chromis. Chromis bromide is the alternate name of that. Alrighty, so this next one here is CuCO3, and what we need to do is we need to have the number here and the number here. There's actually a parentheses around every polyatomic ion, and the number, this CO3 is carbonate, and carbonate has a 2- charge. So in order to have these numbers here reduce, then that means that this must be also a 2+ charge. Otherwise, then that 2 would be there, and then this number, whatever it would be down here too. So because they are reduced, then this is copper Roman numeral 2 carbonate. So copper Roman numeral 2 carbonate. And then that would be cupric, because there are 2 different charges on copper. All right. I can't emphasize enough how important it is to have memorized your periodic trend charges and your polyatomic ions. You just cannot do this without it. All right. So really actually memorize them. Okay. This next one is iron. Iron. Iron has multiple different charges, and this is dichromate. Now we need to figure out what is the charge on this iron. Okay, and knowing the charge on the dichromate, which is a 2-, and that was something that was memorized, that means that this charge comes down here like that. And then this charge right here comes down here like that. Well, these 2 charges disappear, if you will, so they reduce. That means that this is a Roman numeral 2. So this is iron 2 or ferrous. Dichromate, one or the other. All right. All right. Now we're going to do another one here. This is iron and sulfate. Iron and sulfate. This also needs a parentheses here with a number. And this one is easier to see because it's not reduced. So this 3 comes up here. This 2 comes up here. What's the charge on the sulfate? It's a 2-. What's the charge on the iron? In this case, it's a 3+. So it's iron Roman numeral 3 sulfate or ferric sulfate. All right. So hopefully that's making sense to you. All right. By the way, this video is brought to you by and sponsored by the Crazy Hat Chemist, where you can get all your chemistry needs met, hopefully. All right. You have hopefully watched my lecture video on this entire series, which discusses how I go about this as well. So you should have watched the lecture video prior to watching this video, hopefully. So if you haven't watched the lecture video and you're starting on this fresh, then that's a bad idea. If you have not memorized your polyatomic ions and your periodic trends, then that is also a bad idea. All right, so let's keep on going. This is sodium. Sodium, because it's in group 1, will never have a Roman numeral. Okay, and then this is acetate. That is just a polyatomic ion that you just have to flat out memorize. This is lithium and then hydrogen. Now, this is a very unusual case where we have hydrogen as an anion. So there are two cases in which hydrogen can be an anion, and that is an H1 minus. So that is when hydrogen is combined with any group 1 or group 2. So that's an alkali metal or an alkaline earth metal. That's when hydrogen takes the non-dominant charge, and that is the group 1, the alkali metal takes the 1+ charge, the alkaline earth metal takes the 2+ charge. So this is lithium, and then hydride. That most certainly will be on your test as well. Okay, this next one is HBr. Now, this one actually needs and requires this AQ. Okay, if it did not have the AQ, then this would be hydrogen bromide. But with the AQ, that means that this is an acid. And this is a binary nonmetal acid. Binary, 2 elements. Okay, nonmetal, that's a nonmetal. So it goes by a certain naming. That certain naming is hydro ic acid. So all binary nonmetal acids have what I have in blue. That is hydro root word ic acid. Hydro root word ic acid. That's binary nonmetal acid. They need the AQ. If it weren't for the AQ, if I just were to place my weight over the AQ, then, well, there, now we can't see it. That would be hydrogen bromide. And without an acid. Okay. Coolio. All right. So that's hydrobromic acid. And then here we got potassium. And this is a polyatomic ion that is hypobromite. Again, if you don't know your polyatomic ions, then that's going to be really, truly impossible. Okay, this is chromium. And there's going to be a Roman numeral and hypochlorite. And what is the Roman numeral? There it is, right there, Roman numeral 3. So chromium hypochlorite or chromic hypochlorite, either one or the other, doesn't really matter. Next one, this is a binary nonmetal. That is, it has 2 nonmetals and it's going to use prefix naming. So when there's only 1 for the first element, you don't write a prefix. When there's more than 1 for this first element, you have to write a prefix. So when there's 1 for the first element, as in this case, it's just the element name, carbon. And you always use a prefix for the second one. And the prefix for 3 is tri. So it's carbon, tri, and then the name of this element is oxygen, but it will have the IDE ending on it. So trioxide, right? Fantastic. All right, gonna move this up here just a little bit so we can see some more of these. All right, this next one is cadmium. All right, so cadmium. And this is per or hyperiodate. You can write hyper. Either one, it's hyperiodate or periodate. Most commonly, chemists get rid of the hyper, the HY part of the hyper. Okay. All right, this is also a binary non-metal. Okay, so I have 2 nonmetals. I have to use prefix naming. There's only 1 carbon, so in the front, though, so it's carbon. And there is 1 element in the second element. There's only 1 of them. So you have to use a prefix for the second element. The prefix for 1 is mono. So it's monoxide. Okay, and just so that you know, so one of the rules is we have mono and then oxide. Okay, you cannot put two vowels together of A's and O's. So what you're going to do is chop off the vowel on the prefix. So that way it's not monoxide or something like that. It's just monoxide. And you do keep the vowel on the element itself. And it will have an IDE ending on it. All right. This is also a binary nonmetal, that's sulfur. And then dioxide. Di is a prefix for two, and then oxide. It's okay to have these two vowels of an I and an O, that's okay. Right? All right, this next one over here, this is kind of like an A problem on this next one here. It is sodium peroxide. Many people think that you can reduce these twos, but you cannot because the peroxide is O2 2 minus. This two right here cannot be reduced. So that's why you cannot reduce that any more than what it is already on that one. Okay. All right. Coolio. Awesome. This is cobalt and Roman numeral 3. And this is permanganate. And then this is cobaltic. It's the higher charge. Cobaltic permanganate. That's the other way of writing that. All right. Awesome. So I'm going to peel this away and we are going to keep on moving. And let's do, that was number 34. So we're going to be doing 35. By the way, just so that you know, I have 150 problems. That's 150, 150 problems. I'm going to let you know, you cannot get enough practice on all of this at all. The more practice you have, the better off you're going to be able to answer all the questions on your chemistry test. And the better off you're going to do in future units, because future units are going to be dependent on how much information you know on your nomenclature. It's really a year-long process, so please know it. All right, this next one here is SN, so that is tin. And the Roman numeral for that is 2. There it is right there. I've circled it in the blue. And then this is arsenate. The common name for tin, that's Roman numeral 2, is stannous. Next one is sodium cyanide. And this is a polyatomic ion. By the way, I do want to mention this also here, and that is spelling counts. Okay, there are many of the polyatomic ions and element ending names that they are very close to each other and one letter difference. And that one letter difference will mean a world of difference. So make sure that you realize that spelling counts on all of this, on all the nomenclature. So it's very important. Okay, the next one is cadmium. And there is only one charge on cadmium. That's a periodic trend. And this is a polyatomic ion, phosphate. All right, and just so that you know, this 2 comes up. So cadmium is a 2 plus. How do I know it's a 2 plus? Well, where is cadmium? It is right there. See, there's cadmium. It's a 2 plus. Silver 1, zinc 2, aluminum 3, zinc and cadmium 2 plus. So it's a 2 plus. What's the charge on phosphate? It's right there. It's a 3 minus. Okay, so I'm hoping that you understand that. This next one is calcium. And this is also, this is not like dihydrogen or anything like that, okay? This is, we had a previous problem, and let me see if I can remember. This is just like problem number 25, which was lithium hydride. This is calcium hydride. So this is when hydrogen takes the anion charge, okay? All right, hopefully that works for you. All right, number 39 is potassium. And this is hydrogen sulfate or bisulfate. So hydrogen sulfate, or the common name is bisulfate. You need to know both the systematic name of hydrogen sulfate and bisulfate. All right, scrolling this baby on up, we have tin. What's the charge on the tin? It's right there. It's a 2. So it's tin, Roman numeral 2, and then nitrite. And that is stannous for the tin that's a Roman numeral 2. All right, now we have a 41, that's sodium. And SCN is thiocyanate. That is a polyatomic ion. You just have to flat out memorize that. Okay, this next one here is SnCO3. Now, this one is a complicated one. There's a 1 here and a parentheses and a 1. I'm going to flip up the 1 and I'm going to flip up this 1. Okay, there is no tin that's a 1+ charge. And carbonate is a polyatomic ion. It is a 2- charge. And because these numbers right here have been reduced, that is, you cannot see them, that means that this 2 and this 2 are also reduced. So hopefully that makes sense. So this is tin, Roman numeral 2, carbonate. Tin, Roman numeral 2, carbonate, or stannous, carbonate. Okay. All right, this is gold. Gold, Roman numeral, chloride. And what's the charge on the gold? It's a 3, so Roman numeral 3. And that's auric, A-U-R-I-C. That's the higher charge of that. Scrolling on up. Okay, this is also a complicated problem here. It is tin sulfide, tin and parentheses sulfide. And this is the A problem right here. This separates the A's from the B's, if you will. So this 2 will come up, and it looks like it's tin 2. And then this 1 will come up. But sulfur is not a 1- charge. It is actually a 2- charge. So in order to maintain the 2-to-1 ratio, I need the tin to be a 4+ charge to maintain the 2-to-1 ratio. So that's why this is going to be tin, Roman numeral 4, or stannic. Sulfide. That's a complicated problem here. That separates the A's from the B's. Okay. This has AQ, which designates that it's an acid more than likely, and it is a polyatomic ion acid. So that AQ does not actually have to be there on this problem on 45. It is. But so what we're going to look at is sulfate. Sulfate, so H becomes ic when you're doing acids. So this is sulfuric acid. And there's a spelling issue on this, and I highly recommend that you watch my lecture video series on this. Otherwise, this is not going to make sense. Okay, this is going to be iron, and the charge on the iron is 8,2. So this is iron, Roman numeral 2, and iodate. And that is ferrous. Oh, by the way, I don't date anymore. I'm not iodating anymore. Oh, definitely not. I am married to my lovely wife. I love my wife. Absolutely. Here we go. Next one is PB. That's for lead. What's the charge? 4. So lead. Roman numeral 4. Hydrogen carbonate. running out of space there, so let's slide that over. So lead Roman numeral 4 hydrogen carbonate. Okay. This also has, actually, this has 4 different possibilities. So this is plumbic and bicarbonate. So you can have lead 4 hydrogen carbonate. You can have plumbic bicarbonate. You can have lead 4 bicarbonate. And you can have plumbic hydrogen carbonate. So 4 possibilities on that one. That can be complicated. All right, here we go. I'll just leave that up there for a little bit. And then HCl. Now, this is a binary non-metal acid, so it's absolutely essential that you have this AQ here. If you don't have that AQ here, that is going to be a problem. Okay, so that AQ there is essential. And this is hydro root word ic acid. So hydrochloric acid. And I want you to go back and look at number 26 and see that number 26 also has hydro root word ic acid. And I want you to look, and I'm going to pull this back down to number 45 and notice that there is no hydro on polyatomic ion acids ever. No hydro on polyatomic ion acids ever. Okay. All right. Perfect. This next one is going to be hydrogen peroxide. So really what you do is you pull up this 2, that is the peroxide ion, and then there's a 1, a parentheses and a 1, and that's hydrogen. So it's hydrogen peroxide. Okay, that peroxide is a polyatomic ion. This is another acid, and look at that. We have 2 acids in a row here. And this one, there are 2 different ways of writing the acetate ion. This is one way right here of writing the acetate ion. This is actually the preferred chemist's way of writing the acetate ion. This is the condensed formula of the acetate ion. I don't like to write that one really nearly as much. This one is much more useful, especially when you're doing Lewis dot structures. So acetate, 8, you're going to cross that out, it becomes ic, so acetic acid. And that's also the acetate ion, that's acetate. You're going to cross out 8, and you're going to rewrite it and put ic, acetic acid. So there are 2 different ways of writing acetic acid. Notice that the hydrogen is attached to the oxygen here. That's just how we write acetic acid. Acetic acid, every now and then I eat acetic acid, surprisingly. Isn't that amazing? That would be otherwise known as vinegar. All right, so you should be familiar with that one, vinegar. All right, so acetic acid, acetic acid. Now we are going to do our next one, and this is potassium. I'll slide this up just a little bit here. You're missing a little bit of that bottom. There we go. Potassium. And then, oh my gosh, this is a huge polyatomic ion, and that is benzoate. Perfect. This is KMnO4, potassium permanganate. All right, fantastic. And we've got a few more here. All right. Oh, little bit of an advertising plug here. You are watching The Crazy Head Chemist. Please like and subscribe and give me some good positive feedback and comments. If you are learning some cool chemistry stuff, then by all means, please let me know and pass it on to your friends who are in chemistry classes that are not mine. I would appreciate that. Okay. All right, here we go. This is aluminum. And then you'd see the charge on the aluminum is a 3+, and that is correct. And this is hypoiodite. Hypoiodite. That's a polyatomic ion. That's just the name of that. This is also an acid, okay, and this is oxalate. So oxalate. And you cross out the 8, you replace it with ic. So now you have oxalic acid. Oxalic acid. Okay, perfect. That's a polyatomic ion. Notice it does not have hydro in front of it. No way, no how. Holy moly. Okay, cruising on over. We're going to do another set here. I'm sliding on over here to this other side. All right, so this one is an acid as well, but it's a binary nonmetal acid. So a binary nonmetal acid has a hydro. And then the root word is sulf. Then ic acid. So hydrosulfuric acid is the name of that. This is also an acid. This is carbonate. This is a polyatomic ion acid. Notice that this is not a polyatomic ion acid, so use the word hydro in front of it and then the ending ic. This is not a polyatomic ion, so you're going to cross out the 8. You're going to put ic. I ate too much. I feel icky, and yeah. So this is carbonic acid. Okay, all right, perfect. Now we are on to the next one, number 58. And so this is cobalt. And it's Roman numeral 3. And sulfite. That's a polyatomic ion. Or this is otherwise known as cobaltic. Okay. All right, fantastic. And we're going to keep on going here with number 59, scrolling this up a little bit here. There we go. Sodium. And this is a polyatomic ion, thiosulfate. And notice that the thiosulfate has a 2- charge. That's why that is right there like that. This is cesium chloride. Sodium phosphate. Notice that the phosphate has a 3- charge. That's right there. Okay, this is iron, Roman numeral 2. And then this is borate. This is ferrous. Borate. Silver, arsenate. What's the charge on the arsenate? It's right there at that 3. Silver. Arsenate. Okay. And then we have Pb, that's for lead. What's the charge on the lead? Right there. Roman numeral 2. So lead, Roman numeral 2. Hypochlorite. Okay. That's also known as plumbus. Plumbus hypochlorite. Then we have a polyatomic ion of the only polyatomic cation, that's ammonium. Ammonium, and that is sulfate. What's the charge on the sulfate? That is a 2. What's the charge on the ammonium ion? That's a 1. We don't write ones with the parentheses. All right. So this is going to be my first part in this video series, because after this, then we are going to have some names that we're going to have to convert into formulas. So that's going to be the second part of this video. So I'm going to end right there, and I'm just going to remind you that yes, you do need to memorize your polyatomic ions and charges and your periodic trends. So make sure that you know those. I hope you have a good morning, good afternoon, and a good evening, and have a great day. And I'll see you next time. Bye for now.